Hello everyone and welcome to PA Academy. So in this video we are going to be covering the concept of indices. So if you are new to this channel and you are new to subscribe to this channel, kindly click on that subscribe button below to subscribe to PA Academy. Alright, so to start with under indices, the first thing we are going to be looking at is the laws of indices. So if you are looking at indices, there are certain laws that we use in solving questions under indices, and I'm going to be looking at every one of them one after the other. So let's start with its laws of indices. So it's also important to mention that at the end of this video, do just make sure you watch this video to the end, because once you are done watching this video, I'm very sure you'll be able to solve just any question under indices. So let's get started. So the first one I want to use is, if you have something like this, m raised to power a times m raised to power b. So it's also important to note this, that wherever you have it, this I'm currently using alphabet. So when you are solving questions, you'll be using numbers. But once you understand the principles, you'll be able to solve just any question under indices. So let's continue. If you have m raised to power a times m raised to power b, it's the same thing as having m raised to power a plus b. I hope you are seeing it. So just hold on to that one. I'm still going to explain it proper. So if you have something like this again, if you have m raised to power a divided by m raised to power b, it's the same thing as having m raised to power a minus b. So that's the second law. The third law of indices is, if you have anything raised to power 0, so we are using m as the number now. So if you have m raised to power 0, it equals to 1. So any number that is raised to power 0 is equals to 1. But you also have to note that the number itself must not be equals to 0. That means m is not equals to 0. So any number that is raised to power 0 is 1. 1 million raised to power 0 is to give you 1. Alright, so let's look at the fourth one. So the fourth one is like this. If you have an expression like m raised to power minus a, so it's the same thing as having 1 over m raised to power a. You can see doing this will remove the effect of the negative power. So we are going to be having it in this expression. Alright, so let's look at the fifth one. So if you're having an expression like this, m raised to power a, or into brackets raised to power b, is same as having it as m raised to power a times b. I hope we are good. Alright, so let's look at another one. Let's call that as number 6. So if you're having the square root of m, is same as writing m raised to power 1 over 2. So let me also remind you again that all this where we're having alphabets are actually numbers, but just to explain the laws, we are using that's why we are using alphabet. So when I start to explain and analyze it, we are going to be using real numbers. Right, so let's look at the seventh law. So if you're also having m raised to power, now let's use number, or let's still use alphabet, m raised to power a over b. So this is same as having b root m all raised to power a. So one thing you have to note here is, if you're having m raised to power a over b, the same as having b, which is the lower power denominator, then the root, and then the whatever is here, the value itself, let me say the number, all square. So this one at the top, the one at the top will still be the one that will, raised to power a, not square, raised to power a. So these are I've already looked at it and make it reduce it into 4. Reduce it into 7. So you might come across some materials and then you'll be seeing that the laws are maybe 5 or even more than 7. But with these 7 laws of indices, you'll be able to solve just any question under indices. So now let's take a look at these examples one after the other. Now let's start with law 1. So let's analyze it. That's talking about the application of this law. So let's look at the law 1. You say if you have a raised to m raised to power a times m raised to power b equals to m raised to power a plus b. Now this is what it is saying. So let me write it here. So I'm trying to analyze the law 1. So if you're having something like this, 2 raised to power 2 times 2 raised to power 4. So what this is saying is also the same thing as having 2 times 2. Remember, 2 raised to power 2, that's 2 times 2 times 2. Then 2 raised to power 4 is 2 times 2 times 2 times 2. And if you are to write this in indices, that's what? 2 raised to power 7. I hope you are getting it. Now, if you are to apply this, whereby we're having 2 raised to power 2 times 2 raised to power 4, remember this is 2 here, this is 2 here. So we can easily have it as, so if you are to follow this, the law of indices, so you can write it as 2 raised to power 2 plus 4, that will give us, this is 6 here. So 2 raised to power 2 plus 4, that will give us 2 raised to power 6. So this is this when we apply indices, laws of indices. So let me also mention here that it will only work when they are the same numbers here. So let's say we are having 2 raised to power 2 times 3 raised to power 4. So this will not apply because this is 2 here, this is 3 here. So we cannot just say maybe 2 raised to power 2 plus 4, or we say 3 raised to power 2 plus 4. No, we can't use this. So it is only when they are the same. Now an example under law 2 is this. So let's say we have 2 raised to power 5 divided by 2 raised to power 2. So if you are to apply the law of indices, which is this, so where we are having m, we are replacing with 2. So where we are having a, we are having 5, and where we are having b, we are having 2. So if you are to follow this law of indices, you'll be having this as 2 raised to power 5 minus 2, and that will give us 2 raised to power 3. So you can see indices makes it much more easier. Instead of going to the root of having 2 times 2 times, just spreading it out. But if you understand the laws of indices, then this is just what we are having. 2 raised to power 5 divided by 2 raised to power 2. Applying law of indices is the same as having 2 raised to power 3. Are we clear? So let's just check, just to confirm it. So if we have 2 raised to power 5, that is 2 times 2 times 2 times 2 times 2 divided by 2 raised to power 2. That's using this division sign. 2 raised to power 2 is 2 times 2. So if this cancels this cancels this. So we are left with 2 times 2 times 2. So that's 2 raised to power 3. I hope that is clear. Alright, so let's look at an example under law 3. Now, law 3 is more straightforward, that any number raised to power 0 is equals to 1, except from 0 itself. So what it means is that if you have 10 raised to power 0, it's going to give you 1. If you have 1 million raised to power 0 is equals to 1. So anything, any number raised to power 0 is 1, except from 0. So 0 raised to power 0 is not 1. But so any number outside 0 is equals to 1 when we are dealing with indices. So now let's look at an example under law 4. So for law 4, so let's use this example now. So if you have for law 4, so let's say we have 5 raised to power minus 1. Now this 5 raised to power minus 1 can be written as 1 over 5. I hope that is clear. So this has taken the effect of the negative. Now another example is if you are having 8 raised to power minus 3. Using the law of indices, this fourth one, we can rewrite this as 1 divided by 8 over 3. So you can now go further and say 8 raised to power 3 is, so that will be 1 divided by 512. So that is it. When there is a negative power, this is what the principle that you just apply. It's the same thing irrespective of the number and whatsoever. So 27 raised to power minus, let's say minus 8 is the same thing as having 1 divided by 27 raised to power 8. So what this does is it takes out the negative. So that is for number. So log 4. So now let's look at log 5. So if you are finding value in this video, please give it a thumbs up. Now for log 5. Now let's look at this example. If you are having 6 raised to power 2 all into bracket 3. Okay. So if you're having 6 raised to power 2 all into bracket 3, don't forget this as log 5, this is it here. It's the same thing as 6 raised to power 2 times 3, and that will give us 6 raised to power 6. So what we do is to multiply the power. I hope that is clear. What we do is to multiply the power. If you have 3 raised to power 4 all into bracket, let me use 4 again. So it's same as having 3 raised to power 4 times 4, and that's 3 raised to power 16. Now, I hope that's clear. Alright, so let's look at let's use log 6. Now log 6 is similar to log 7. This is log 6 and log 7, but let's still, so if you just have a square root of a number, a square root of, let's say the square root of 2, so you can also rewrite it as 2 raised to power 1 over 2. So if you have square root of 8, any number at all, so in indices you can rewrite it as 8 raised to power 1 over 2. So let's go to 7. So for 7, if you have 8, let me use 8 raised to power 2 over 3. Now this you might be looking at, oh, how do I solve this? But with indices there is a simpler way, which is this. Now let's analyze it using this. So our m is 8, right? Then our a, where we are having a here, we are having 2. And where we are having b, this is our b, and we are having 3 here. So if you are able to analyze it like this, now let's come back and replace it in this way. So this is b root m all raised to power a. So that means we are going to be having 3, then root 8 all raised to power 2. So when you have something like this, you can rewrite it transform in indices. You can rewrite it like this. I hope that is clear. So any number it might be. So if you do this, depending on the question, it allows you to be able to solve the question better. For example, now you can go ahead and solve this, because that will give us, this is 3 root 8, that's the cube root of 8 is 2. That means a number that you can multiply 3 times, that will give you 8. So that's the meaning of this expression, 3 root 8, and that number is 2, because if you have 2 times 2 times 2, it will give us 8. So that means we are going to be having 2 raised to power 2, and this is 4. So what it means is that this expression that we are having here, it might be looking cumbersome, but once you apply indices, the answer is actually 4. So let's look at another one. So it's not all of them might not be straightforward like this, but once you express it like this, it makes it much more easier. So let me just give a random example, still using log 7. So if you have, let's say 50 raised to power 4 over 5. So let me write it properly. So if you have 50 raised to power 4 over 5, so if you are to use indices, you can rewrite this as 5 root 50 all raised to power 4. So just know that the number itself will be under the root sign. Exactly. And the power, the one at the denominator will be coming first. While the power, the numerator at the power will still remain at the top here, will represent the power. I hope that is clear. So with this now, I hope you have been able to get the concept of the law of indices. So the next thing I want us to look at are some random examples. Random examples where we are going to be using some of these laws and some questions. We are going to be using more than one or two of the laws just to solve a single question. So let's take a look at that. So in number 8, we're going to be looking at union. So this is another term that we use in sets, and the notation or the symbol is like this, like a U. Exactly. But it won't have those one that will come down this downward stroke. Alright, so when we talk about union, it's just, so you can say it's a combination. So union is just a combination of all the elements in two or more sets. Exactly. And there's one thing you also have to notice, that, let me put that in brackets, is that no repetition. No repetition of elements when you are considering the union of a set. Alright, so let's look at an example. So if you have a set A with the following elements, and the element in that set A is A, B, and C, and then you have another another set B with the following elements B, C, D, E. Now these are two sets already, A and B, and we are asked to look for the union. So this is how it will look like. So if you, that means you are, maybe if in a question you are asked to look for union, A union B, so that will be A union B. So this is how it will look like. So in answering such question, we are going to be having, so like I said, combination of all elements in two or more sets. Note there will be no repetition. So let's look at that of A. We have A, the element in set A, B, C. That of set B, we also add it together. Now you can see that there is B here, and there's also B. There is C, and there's also C. So there's no need to writing it out again, because we've already write it when looking at the union. So we add D, E, and then we close it. So the union of A and B will give us A, B, C, D, E. So that's what we mean by union. So note that when you are considering two or more sets and you are looking for the union, you don't repeat any set, any elements. And so you don't say because we have A here, or rather we have B here, we have B here, then B will appear two times here. No, just one is that you use. Alright, so let's look at another one that just looks similar. So they call it, that's the number 9. So we call that one intersection. So intersection. So intersection, it has this symbol. Exactly. Like N. But don't forget, it won't have that stroke that will come up, just a curve like this, like N. So for intersection, that is so you can call it a combination of elements similar to both sets. Similar to both sets. Exactly. So now let's consider this set A and set B. So if you have a question and you're asked to look for A intersection B, so you can see this is how when you have a notation like this, that means A intersection B. Exactly. This one is A union B. So if you have a question like A intersection B, that is intersection of set A and set B. So what will it be if you are considering this set A and set B with this element? So that means the element that is similar to or that is common. So let me change this word to common. Exactly. That is common to both sets. So what do we have in both sets A and set B? So if you look at it closely, we only have B and C is here. B is here, C is here. We have B here, we have C here. So that means the intersection A intersection B will be what? B and C. So these are the only element that is common to both A and B. Exactly. Now, if for any reason you are given any question and there is nothing common to the two sets you are considering, that you are putting into consideration, so it's very simple. Let's say the set is, you are looking at set X intersection Y, and when you look at it, and maybe we have set X, for example, and we have the elements in set A to be 2, 4, 6, and then we have the elements in set Y to be, let's say, 7, 8, 9. So now you can see that they have nothing in common. So since they have nothing in common, if you are to look for X intersection Y, it will be a what? It will be an empty set. So you can, and don't forget the notation for empty set is like this, or you can just say X intersection Y is what? Is an empty set. There is nothing in common. Exactly. All right. So we've been able to look at 9 notations or terms that are used in sets. So if you, this is just like the basic, I cover some of the basic of set. So in the next video, we are going to be looking at how to solve questions under sets. Exactly. So that's what we're going to look at in the next video. I'll leave a link to that video in the description. We are going to be looking at how to use some of all these terms in answering questions. So if you find value in this video, please give it a thumbs up. If you are yet to subscribe to this channel, kindly click on that subscribe button, and don't forget to check our website, paacademy.co. So that's paacademy.co, not .com but .co. Exactly. So it's just one word, paacademy.co. So do make sure you check out our website and also subscribe to our channel. So thank you very much, and I'll see you all in the next part of this video.